Question 4. The curve C has the equation y equals f of x. We're given that f dash of x, that's to say the first derivative, is equal to 2x plus a half cos x. The curve has a stationary point with x coordinate alpha. Well, stationary point means that the first derivative is equal to 0. So what we're being told is that when x is equal to alpha, this is going to be equal to 0. So in other words, we're being told that 2 alpha plus a half cosine alpha is equal to 0. Oh, I don't think you can. That's it. Bring this up. Use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places. Well, what they want us to do, the small angle approximation says that if x is small, that implies that cosine of x is approximately equal to 1 minus x squared over 2. And for what it's worth, although it's not part of the question, sine of x is approximately equal to x. These are the small angle approximations. X has to be measured in radians. Anyway, to get back to the question, we have this, and we can replace cosine of alpha, we can replace with 1 minus alpha squared over 2. So 2 alpha plus a half of 1 minus alpha squared over 2 equals 0. So therefore 2 alpha plus a half minus alpha squared over 4 equals 0. I'm going to times through by 4. So I get 8 alpha plus 2 minus alpha squared equals 0. Therefore, alpha squared minus 8 alpha minus 2 is equal to 0. And now we solve this quadratic equation. So alpha will be 8 plus or minus the square root of 8 squared, which is 64, minus 4 times 1 times minus 2, all divided by 2. That gives us 8 plus or minus 64 plus 8, which is 72, square rooted, all over 2. And this time the answers, they can be decimals, can't they? Because that's what they're asking for. So it's going to be 8 plus the square root of 72 divided by 2, which is 8.243. Or 8 minus the square root of 72 divided by 2, which is minus 0.243. Now I must admit I did this question earlier, and when I got this answer I thought it was wrong. The reason being that this doesn't strike me as being especially small. Alpha is supposed to be small, but I wouldn't have thought that 0.243 of a radian would be small. How many degrees is it? It's actually, well, nearly 14 degrees, or, so it doesn't strike me as being particularly small. So I doubt, to be honest, that the small angle approximation could be used. But anyway, that's part A of the question. Part B, the point P, 0, 3 lies on C. Find the equation of the tangent to the curve at P, giving your answer in the form y equals mx plus c. Okay, so what we do, this was part A. Part B, we've got this point P. Let this be the curve. It doesn't really matter what it looks like. Any scribble will do. 0, 3. This is 0, 3. This point lies on the curve. And the question is asking us to find the equation of the tangent at P. So it's asking us to find the equation of this line. Bear in mind my curve bears no relation to the true picture. It's asking us to find the equation of the tangent. Now, to find the equation of the tangent, we need to know what the gradient is. And the gradient, the gradient function is simply f dash of x, because the f of x is the curve and f dash of x is the gradient of the curve. So if I evaluate f dash of x, of course we know is 2x plus a half cos x. If I now evaluate this at 0, it will tell me what the gradient is at 0. 2 times 0 plus a half cosine of 0. Well, that's equal to a half. Cosine of 0 is 1, so this is equal to a half. So therefore, the gradient at P, 0, 3, is a half. So the I'm going to use the formula y minus y1 equals m x minus x1 to find the equation of the tangent at this point P. It would simply be y minus 3 equals a half x minus 0. Or in other words, y equals a half x plus 3. And that's the answer.